Hello everybody. So today we are going to learn about Van-de-graff generator, and this is one general picture of Van-de-graff generator. And as you can see, this lady's hair is flying, and that is because of the Van-de-graff generator. We will know why this happens. Usually, at the beginning of its creation, Van-de-graff generator was used for accelerating particles, but not anymore because that acceleration we needed more, and that was not enough from one Van-de-Graaff generator. Nowadays, people use it to study this electrostatic forces and in special triboelectric effect. So, what is an atom? We know that all the things in the world are made of atoms, but what is an atom? What is an atom made of? An atom is made of protons or positive charge, electrons or negative charge, neutrons or no charge. These protons are concentrated very much inside the nucleus, and the electrons are outside. The neutrons are the ones that have no charge. Protons provide the majority of the mass, while electrons provide minimal amount of mass. So this is what an atom is made of. This is how it works. There are a mixture of neutrons and protons concentrated at the nucleus of the atom or the center of the atom, and the electrons keep revolving in the orbits around them. So this is a small example of analogy of how to understand the revolving of electrons and the presence of protons and neutrons in a atom. And one of the analogies is most probably planets orbiting the sun and the sun in the middle of all the orbits. Where are the basketballs and the tennis balls located? So as you can see, this speaks about the location of electrons, protons, and neutrons in the atom. We have already known that. We'll be moving to the next slide. Now, an important part of electrostatics. Like charges repel and opposite charges attract. A very important law which says that if you keep opposite charges together, it'll attract each other. If you keep like charges together, they will always repel. Just like in magnetism, if you keep like poles together, they will repel, and if you keep unlike poles, they will attract each other. Next, this is a small presentation about like charges and unlike charges repelling. Now, glass rod and a silk cloth demo. This is a phenomenon we observe in everyday life, but we never know the reason behind it. So let's speak about this a little bit in particular. Here is a glass rod and a silk cloth. The silk cloth has positive charges on one side, negative charges on one side. Similarly, the glass rod has positive charges on one side and negative charges on the other side. Now, when you rub this silk cloth on this glass rod, the positive charges from the silk cloth are going to fall onto the glass rod, and the negative charges from the glass rod are going to go on to the silk cloth. And this is because of electrostatics. So, this is a very important example to understand this very simple concept that happens in our day-to-day life. Now, if you take this glass rod and put it near your hair will stand up. Why? Because it is positively charged after rubbing with the silk cloth. Next, hair and comb demo. Just like I said, where there is a glass rod over there, and here there's a comb. If you rub the comb on your hair continuously, yeah, the hair moves electrons from your hair to the comb. Yeah, combing your hair moves electrons from your hair to the comb, and the comb will now have an electrostatic charge, which is negative, and that's how if you keep the comb near your hair again, it will stand at the end. Now coming to the Van-de-Graaff generator and how we will use all these principles. So the basic fundamental principle behind a Van-de-Graaff generator's apparatus is separating opposite charges at both ends of the rubber belt or cotton belt. Most of the time it's a cotton belt, and today I'll be explaining about a Van de Graaff generated using a cotton belt. So yeah, the basic fundamental principle lies behind separating the opposite charges. And the key materials used in a Van de Graaff generator are a motor, and this is a metal sphere. There's also a conveyor belt, which I told is made of cotton, the one which I'm going to explain. And there is a presence of two combs and two rollers. Those rollers can be made of any material, but the one at the top is made of aluminum. And let's get into the one diagram generator in detail. Yeah, just like I said, rollers and brushes. How it works. Now, this is a very interesting concept. So, what happens is when the motor at the bottom rolls around, what it does is due to friction with this cotton belt, cotton conveyor belt, this roller becomes negatively charged, leaving only positive charge on this cotton, and this moves on to the conveyor belt. What happens to this comb? Why is this comb here? This comb is here because, of course, it's neutral, but when the roller is negatively charged, this comb gets positively charged because this negative charge attracts positive charge. Just like I said, unlike charges attract each other, right? So this comb gets negatively charged, sorry, positively charged, and the negative charge goes away. So when this comb becomes positively charged and there is an negative charge over here, because of the electric field, some protons try to jump on this roller. But since there is a conveyor belt in middle, these protons go on into the conveyor belt and mix with them, increasing a few number of protons on or positive charge on this conveyor belt, and that's the use of this comb at the bottom. Now, when this positively charged conveyor belt goes here, because of the aluminum nature of the top roller, it tends to lose electrons. So when it tends to lose electrons, the protons of the positive charge from here enter into this roller, and the same story repeats again. What happens is, since it is positively charged and the comb is neutral, the comb becomes negatively charged, and there is an electric field in between here. It tries to attract these electrons, and the protons in the comb, they flow out from here into the metal sphere. So basically, we separated all the charges, and at the end, we are supplying this positive charge to the metal sphere. And as long as this conveyor belt keeps rolling, there's an accumulation of positive charge over here, unless and until we try to discharge it with another conducting sphere on the other end. So that is how a Van de Graaff generator works. Based on a simple principle of separating charges, they built an electric discharge, which is very amazing, by the way. So this is a presentation of what type of charges are present on our hair, and this is how our hair stands on its end when we put our hands on a Van de Graaff generator. Because our hair is positively charged and there is positive charge accumulation, and as I said again, like charges repel each other, this man or any other guy in this place, this the hair will stand on it because there's a repulsion between them. And this is an enhanced version of Van de Graaff generator. Like I told, they were used to accelerate particles and create lots of discharges. And this one is called the electric spark with a Van de Graaff generator. So this is a genuine question. Has anyone felt a shock on dry winter days? Because since we studied the Van de Graaff generator, let's talk a little bit about this. Why anyone felt a shock on dry winter days? Again, this is because of the same fact of separation of charges. It is called static shock. and this is explained by the same phenomenon. Yeah, I forgot to explain to you one thing. When the roller becomes positively or negatively charged, when the conveyor belt is rubbing on it, and the same happens on both sides, this effect is what is called the triboelectric effect. And this is the main fundamental principle behind the Van-de-Graaff generator. And the triboelectric effect is the same culprit over here. Why do you feel a shock on driving today's? Answer, I think it's triboelectric effect. So, thank you everybody for listening to me. I hope you liked it.